Hello students, today we are going to learn the R and S configuration. This is the absolute configuration that is used to determine the structure of a molecule that has a chiral center. The term R is derived from the Latin word known as rectus, which means clockwise, and the S is derived from the Latin word sinister, which means anti-clockwise. If we see, the R is going the clockwise, and for the S it is the anti-clockwise. So in this way we assign the configuration R and S to the molecule having the chiral center or the stereo center. Now how to assign the configuration to the chiral center? So there are certain set of rules to assign the configuration to the chiral centers, which are known as the SIP rules, Kahn-Ingold-Prelog rules. So we will first learn the SIP rules to assign the configuration, and after that we will see the examples. So first rule says that we have to assign the priorities to the atom that is bonded directly to the chiral center, and these priorities are assigned based on the atomic number of the atoms bonded directly to the chiral center. Now first it is necessary to understand what is the chiral center. Chiral center is any sp3 atom that is bonded with different groups. For example, if the carbon is sp3 hybridized and if it is bonded to 4 different groups, then that carbon is known as the chiral carbon, or that particular atom is also known as the chiral center in the molecule. The priorities are assigned by the numbers 1, 2, 3 and 4, where 1 denotes the highest priority and 4 denotes the least priority. Greater is the atomic number, greater is the priority. So now we can see here, this is the chiral carbon. It is bonded to 4 different groups: bromine, chlorine, fluorine, and this is a methyl group. The methyl group is bonded through carbon. So we have to consider bromine, chlorine, fluorine and carbon of the methyl group. Now atomic number of bromine is 35, chlorine is 17, fluorine is 9 and that of carbon is 6. So the group with the highest atomic number is assigned the highest priority. So first priority will be given to bromine, second priority will be given to chlorine, third priority will be given to fluorine, and fourth priority will be given to carbon of the methyl group. So in this way the priorities are assigned. Here we have directly given the name of the compound, but how to assign the descriptor R and S? Okay, we will learn it after we complete the rules. Now second rule says that if two atoms bonded directly to the chiral center happens to be isotopes of each other, then in that case we have to assign the priority based on the atomic mass. We know that isotopes are atomic species of the same element that has the same atomic number but different mass number. So here we have taken the example of deuterium and hydrogen. Deuterium is the element that has the atomic mass number equals to 2 and atomic number equals to 1, whereas hydrogen, which is also known as a protium, has the atomic number 1 as well as the mass number 1. So there is a tie between the deuterium and hydrogen because both have the same atomic number. So in that case deuterium will have the higher priority over the hydrogen. So first priority will be assigned to bromine, that has atomic number 35. Second priority will be assigned to the carbon of the methyl group, that is atomic number 6. Now there is a tie between deuterium and hydrogen, so we will assign the priority based on the atomic mass. Hydrogen has atomic mass number equals to 1, whereas deuterium has atomic mass number equals to 2. So greater the atomic mass, greater will be the priority. So deuterium will be assigned third priority and the hydrogen will be assigned the fourth priority. Now in case if the electron pair is present, then electron pair is assigned always the least priority, even lower than hydrogen, because as per the rules we are assigning the priority based on the atomic number, and atomic numbers are the total number of protons present in any atom. So if the electron pair is present, then it will assign the least priority, even a lower priority than hydrogen. Now third rule, in case if the group bonded to the chiral center is through the identical atom, then atomic number of atoms of the same groups are identified till the first point of difference is reached. The higher priority is assigned to that group that has the atom with the highest atomic number or with a higher atomic number at the first point of difference. So here we have the two groups, methyl and ethyl. Okay, say for example, if we start with the carbon of the methyl, then we will have the 3 hydrogens. And if we start with the carbon of the ethyl, then we will have 2 hydrogens and 1 carbon. So here we got the first point of difference. The atomic number of hydrogen is 1, that of carbon is 6. So in this case, the ethyl group will be assigned the higher priority over the methyl group. Let's understand this with example. So here we have the S-butane 2-ol. Here we have chiral center. This is the chiral carbon. To this chiral carbon, the hydroxyl group is attached, methyl group is attached, hydrogen is attached, and ethyl group is attached. So first, the priority will be assigned to oxygen of the hydroxyl group because it has atomic number 8. Hydrogen will of course will have the priority 4 because its atomic number is 1. Now if we see the methyl group, then it is bonded through the carbon to the chiral center. Same way, if we see the ethyl group, it is bonded to the chiral center through the carbon. So now there is a tie between these two carbon atoms because both have same atomic number. So we will search the first point of difference. So now this carbon is further bonded to 2 hydrogens and 1 carbon, whereas this carbon is further bonded to 3 hydrogen atoms. Now this carbon has a greater priority over the hydrogen, so ethyl group will be assigned the priority 2 and the methyl group will be assigned priority 3. So in this way, if the groups bonded to the chiral center are through the identical atoms, then we search for the next possibilities till we reach the first point of difference. In the first point of difference, the group will be assigned the higher priority if its atom has a higher atomic number. Now what happens if there are complex alkyl substituents like this? So for a complex alkyl substituents, we have to proceed along more branched chain of the substituents to find the first point of difference. So imagine that this carbon is bonded to the chiral center. So if we click on this carbon, then we have carbon, hydrogen and carbon. Now if we see, there is CH2Cl group and here we have the more complex substituent carbon. So we have to proceed along that chain which is more branched. So we will click on this second carbon. So here we have carbon, carbon and carbon. Now if this carbon is bonded to the chiral center, then we have carbon, carbon and hydrogen. So it is HCC. So there is no first point of difference here. Now we will proceed along the more branched chain. So this is carbon, hydrogen and carbon. So it is HCC. So here we got the first point of difference. So if we have to assign the priority between these two groups, then the first group will be assigned the higher priority because at the first point of difference, we have the carbon with the atomic number 6 and for the group 2, we have the hydrogen with the atomic number 1. So at the first point of difference, this atom has a higher atomic number. So if we have to assign the priority, then the group 1 will be assigned higher priority over the group 2. Now rule 4, if the groups bonded to the chiral centers have multiple bonds, that means either double bond or a triple bond, the atoms of the group that are bonded with the multiple bonds are duplicated and if they are bonded through triple bonds are triplicated. So except hydrogen, all the atoms bonded to the multiple bonds are assigned valence is equal to 4. Now we know that nitrogen and oxygen are designated by the phantom atoms with a subscript 0 as they have the valency less than 4 and the phantom atoms are assigned with the least priority. Now say for example we have a cyanide group where we have C triple bond N. So this is the carbon of the cyanide group and we have C triple bond N. So we will assume that there are 3 carbon nitrogen single bonds. Okay, so this is the carbon which is bonded with 3 nitrogens. On the opposite side, there will be the nitrogen carbon single bonds. How many bonds? 3 bonds because both are bonded with each other through the triple bond. So nitrogen, this is the first bond, this is the second bond and this is the third bond. Okay, so nitrogen is bonded with a single bond with the 3 carbon atoms. Now in the molecule we see there is only one carbon bonded to one nitrogen. So rest two carbons will be the phantom carbons. Similarly, the carbon is bonded here to one nitrogen through the triple bond. So rest of the two nitrogens will be the phantom atoms. So if we check the group, then carbon here is bonded with three nitrogens and the nitrogen is further bonded with three carbons. This is known as the triplication. Same is the case with the carbonyl group. Here we have carbon bonded with hydrogen and double bonded with oxygen. So we will assume that there are two carbon oxygen single bonds. So if we click on this carbon, then we see that there are two carbon oxygen single bonds. And further, there will be two oxygen carbon single bond. One single bond is with the original carbon atom and second will be the phantom atom. So the priority will be H, O and O. So in this way, the bonds are either duplicated or triplicated. At last, we have to assign the configuration R and S depending upon the priorities assigned. After the priorities are assigned to the groups bonded to the chiral center, we have to view the molecule from the side opposite to the least priority group. So here we can see the molecule is viewed or arranged in such a way that the least priority group, that is the fourth group, is away from the viewer. After that, we have to rotate our eyes in the decreasing order of priority, that is 1, 2 and 3. If our eye rotates in a clockwise direction, assign the configuration R, and if the eye rotates in anti-clockwise direction, assign the configuration S. These were the SIP rules that are used to assign the R and S configuration. Now let's understand with examples. So here we have a molecule which is 2-bromobutanone. If we rotate the molecule, we can see the chiral carbon is bonded to four different groups, that is bromine, methyl, vinyl and hydrogen. So first we will bifurcate the four different groups. We have the bromine, we have methyl, we have vinyl and we have the hydrogen. The atomic number of bromine is 35. So it will assign the highest priority. And the atomic number of hydrogen is 1. So it will be assigned the least priority. Now there is a tie between the methyl and the vinyl because both are bonded with the same carbon. So if we check the methyl, then the carbon of the methyl is bonded with 3 hydrogens. And here we have carbon double bond carbon. So we have to duplicate the group. So this will be the phantom atom. Similarly, this is the phantom atom and we have 2 hydrogens here. Now if we check this, this is the carbon which is bonded to the chiral center. It is further bonded to the carbon, hydrogen and carbon. So this will be assigned the second priority and methyl group will have the third priority. Bromine will have the first priority. Vinyl group will have the second priority, methyl will have the third priority and the hydrogen will have the fourth priority. So we have to view the molecule from the opposite side of the least priority group. Now if we rotate our eyes in the decreasing order of priority 1, 2 and 3, the eye rotates in the anti-clockwise direction. Okay, so the configuration of this molecule is S. Now come to butane 2,3-diol. So here we have the two chiral centers, carbon 2 and carbon 3. We will assign the configuration to each chiral centers. Now for carbon 2, what groups are bonded? The hydroxyl group, methyl group, and there is one bulky group, that is CH, OH, CH3. And last is the hydrogen. So oxygen has the atomic number equals to 8. So it will be assigned the first priority. Hydrogen has the atomic number equal to 1. So it will be assigned the least priority. Now there is a tie between the carbon of the methyl group and the carbon of this bulky group. So if we check this, then methyl carbon is further bonded to 3 hydrogens. And for this, the carbon is bonded to hydrogen, oxygen of OH and carbon. So here for this carbon of the methyl group, they are further bonded to hydrogens. For this carbon, they are bonded to hydrogen, oxygen and carbon. So here we got the first point of difference. So this group will be assigned the higher priority. So it will be second and this will be third. So now let's assign the priority. OH will be assigned the first priority. Then this hydrogen will be assigned the fourth priority. This group will have the second priority and the methyl will have the third priority. So we will view the molecule from the opposite side of the fourth priority group, and we can see when we rotate the i's in decreasing order of priority 1, 2, 3, the I rotates in a clockwise direction. So the configuration of this second chiral center is R. So we will write here 2R. The same situation follows for the third chiral center. Okay, because the groups bonded are identical. For the third chiral center, the OH will be assigned the first priority. The methyl will be assigned the third priority. This bulky group will be assigned the second priority. And the hydrogen will be assigned fourth priority. Viewing the molecule from the opposite side of the least priority group, we can see that our I rotates in an anti-clockwise direction. So the configuration of the third carbon is S. Okay, so this molecule can be said 2R3S butane 2,3 diol. Now we have here the cyclic molecule. Let's understand how to assign the configuration in the case of the cyclic molecules. So here we have a ring structure. Here we have a bromine and here we have a double bond. So this is the fourth carbon and we have hydrogen too. So because this is the sp3 carbon, so here there are bromine and hydrogen. This is the chiral carbon. So we have to assign configuration to this chiral carbon or the chiral atom, and this carbon is fourth carbon. Now let's see what groups are bonded to this chiral center or the chiral carbon. First we have a bromine and we have the hydrogen, which we can see clearly. Now this is a cyclic compound. In a cyclic compound, the chain is closed. So in that case, we will start with the bromine. Then we will move in the anti-clockwise direction as well as in the clockwise direction. When we move in anti-clockwise direction, we have CH2 double bond CH. And now if we move in the clockwise direction, then we have CH2, CH2, CH. Okay, let's understand again. If we move in the anti-clockwise direction, then we get CH2 starting from this carbon. Okay, starting from this carbon, if we move in the anti-clockwise direction, we have CH2, CH, double bond CH. And if we start in a clockwise direction, then we have CH2, CH2, CH double bond CH. So in clockwise and anti-clockwise direction, we have the different environment. That means this carbon is chiral. So if we go in an anti-clockwise direction, then we have CH2, CH double bond CH. And in the clockwise direction, we have CH2 and last there is a hydrogen. Now this CH2 and this entire group are bonded through CH2. So here we have the CH2 group. So this is the priority 1, 2, 3 and 4. Okay, because here there will be the bond duplication. Bromine will be assigned the highest priority because its atomic number is 35, and the hydrogen will be assigned the least priority because its atomic number is 1. Now if we rotate the molecule, then this group CH2, CH double bond CH will be assigned the second priority, and this group, that is CH2, CH2 group, will be assigned the third priority. Rotate the molecule so that the least priority group goes away from the viewer. We can see in the decreasing order of priority, if we rotate the ice is getting rotated in a clockwise direction. So this molecule has a configuration R at the fourth chiral center. Okay, so the configuration will be 4R. Now here we have 3 bromo cyclohexane 1-ol. So let's understand how to assign the configuration to this molecule. Okay, so there is a 6-membered ring. On the first carbon we have the OH, and starting from this first, this is the first, this is the second, and this is the third, we have the bromine. So this is the third carbon. We have to assign the configuration to both first carbon as well as third carbon. So what is the scenario for the first carbon? Of course, here there is a hydrogen, and here there is also hydrogen. So what is the configuration at the first carbon? What groups are bonded to the first carbon? OH. Oxygen will have the highest priority since its atomic number is 8. Now since the compound is cyclic, you have to go anti-clockwise as well as clockwise. When you go anti-clockwise, you have CH2, 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 CHBr, okay, and CH2. And when you go in a clockwise direction, then we have CH2, CHBr, CH2, CH2, CH2. So in both the cases, environment is different. So first carbon is a chiral carbon. So if we go in a clockwise direction, what environment we are getting? We are getting CH2, CHBr, CH2, CH2, CH2. And if we move in anti-clockwise direction, what environment we are getting? We are getting CH2, 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 CHBr, and CH2. We can see on the second carbon itself, we are getting the first point of difference. So this group will be assigned the higher priority. So it will be CH2, CHBr, CH2, 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 and last will be hydrogen. So this will be have the first priority, second, third, and fourth. If we assign the priorities on the first carbon, the OH will have the highest priority. Then we rotate the molecule. Hydrogen will have the least priority. So it will be assigned number 4. The group which is marked with a purple color will have the second priority. And the group that is marked with the green color will have the third priority. And we will view the molecule from the opposite side of the least priority group and rotate the eyes in the decreasing order of priority 1, 2, 3. We see that eye rotates in a anti-clockwise manner. So this carbon has a configuration S, and it is the first carbon, so the configuration will be 1s. Again we are taking the same molecule to assign the configuration on the third carbon. So here OH, Br, and H. Now this is your third carbon, this is the first carbon. Okay, so starting from the third carbon, which is our chiral center, we have the group bromine. So bromine has a Z or atomic number 35, so it will have the highest priority. Hydrogen will of course will have the least priority. We have to go in a clockwise direction as well as in the anti-clockwise direction starting from this chiral center. If we go in the anti-clockwise direction, then what is the environment? The environment is CH2, CHOH, CH2, CH2, CH2. And if we go in the clockwise direction, what is the environment? We have CH2, 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 CHOH, and CH2. We can see on the second carbon itself, we are getting the first point of difference. Moving anti-clockwise will be preferred while assigning the priorities. So in case of the third carbon, the priorities will be bromine followed by CH2, CHOH, CH2, CH2, and hydrogen. So 1, 2, 3, and 4. In this way the priorities will be assigned. 1, hydrogen will be of course 4. Now rotate the molecule to view the groups clearly. So the group that is highlighted with a purple color will have the second priority, and that with the green color will have the third priority. And after assigning the priority, view the molecule from the opposite side of the least priority group. We see in the decreasing order of priority, the eye is rotating again in an anti-clockwise direction. So on the third carbon, the configuration will be S. So this molecule is 1s3s, 3-bromocyclohexane 1-ol. In this video, we learn about the SIP rules to assign the priorities to the groups bonded to the chiral center, and we learn about the assigning the configurations to the chiral centers.